Okay, let's start off by reviewing some vocabulary. You got this vocab on day 1, and we haven't really talked about these words very much, so let's make sure we know what these words are, because we're going to learn some theorems about them today. So, number 1, draw a diagram of vertical angles named GHI and MHN. We learned when we got our vocabulary that to make vertical angles, we have to have the letter X. You have to have the letter X. So hopefully you drew the letter X on your paper. Name one of them, GHI, and name the other one, MHN. Now, that's 4 angles. That's 4 angles, so I need to make sure I mark them. I'm going to go ahead and just put a 1 and a 2 to show those are the ones that are my vertical angles, GHI, NHM, those exact angles. The other 2 are vertical too, but those are the ones we were told to name. Number 2, complementary. So we need angles that add up to 90 and adjacent. Adjacent means next door neighbors. Share a ray. The 2 angles share a ray. They're next to each other. So you needed to maybe start with a right angle. Remember, that angle is not complementary. That's just a right angle. And now I want 2 angles that add up. I don't want to assume it's an angle bisector, so I didn't put it in the middle on purpose. So we've got A, B, C, and C, B, D. Here's what we wouldn't have done. This is important, because I had people do this. We would not have put A, B, C like that, because it's one of our complementary angles. Well, if it's 1 in a complement, it can't be 90 by itself. That's not how complementary angles work. So we needed to have the C here. We had no choice. So angles 1 and angle 2 are adjacent and complementary. I'm just trying to use those vocab words a lot to get you used to it. Last one, go to your vocab sheet if you forgot what this means. In the word linear, I see the word line. Well, that's a big hint. Let's draw a line. And in the word linear pair, I see the word pair. Pair means 2. Doesn't mean 3 or 1. It means exactly 2. So I've got 2 angles that together form a line. QR, I have to put the S up there. QRS, so that's one of my linear pair angles. And then SRT. Yours might look different as long as they fit the qualifications of the line and the pair. Okay, vocab, yay! Now we're going to take some notes. Title it Special Angle Pairs. Drew 2 intersecting lines. Check. We're pretending. Then we labeled the angles 1, 2, 3, 4. Then we got out some patty paper. So we've got our clear tracing paper. And we started tracing these angles to compare them to one another. So we traced angle 1. And then we went over and we tried to compare it to angle 2. Oh, they're different. Those aren't the same angle. And then we came over here, whoa, and we compared angle 1 to angle 3. When we traced it and then compared it, what did we find about angle 1, the measure, and the measure of angle 3? Yeah, you're finding, hopefully, that they're the same measure, because when you traced it and put it on top of the other angle, it filled the exact same rays. It was this made up of the same rays at the same angle. So if I did the same to angle 2 and compared it to angle 4, whoa, I'm getting the same measure. So angle 2 has the same measure as angle 4, and angle 1 has the same measure as angle 3. What's the vocab word for these? You already said it. No, they're not adjacent. No. They're vertical angles. So let's develop a theorem. This doesn't just happen in my picture. This would happen no matter what kind of intersecting lines, even if they looked like that, even if they looked like that. it would have happened with any intersecting lines. So we can write a theorem because it always happens. Trust your teacher. The theorem is if two angles are vertical angles, so that's the hypothesis. First, they need to be vertical. The conclusion is then they are congruent. If two angles are vertical angles, then they are congruent. Did one of you have patty paper? That's awesome. So go ahead and write this. There's two theorems that we're adding to our notes today, and we're going to be using these theorems a lot in the future. A lot. Good. Sometimes when I talk about this theorem, many times, I'm going to abbreviate it as the VAT, because we're going to use it so often. I'm going to be tired of saying vertical angle theorem, so I'm going to call it, and why is that true? Oh, by the VAT. And when I say by the VAT, I mean vertical angle theorem. All right, so let's look at these lovely pictures from the real world. There's vertical angles all around us, so let's just mark some of them for fun. Let's look at the railroad crossing. Easy to spot those, right? Angle 1, angle 2, I should use a lighter one. Here's a lovely design on some outdoor concrete. Ooh, even the propellers of a helicopter could, they don't always, but they could form some congruent vertical angles. A bookshelf. A bookshelf is full. Let me get a lighter one. Bookshelf is full of vertical angles. Even the hands of the clock. Even though those don't go very far, even the hands of the clock make some vertical angles. There's an angle there. Even though the ray doesn't extend very far, there's an angle there. And then this one's a bit harder to see. I guess I could do this whole angle, angle 1, and then it's so thick it's hard to see. So there's even vertical angles in countries' flags. All right, let's make sure we understand what vertical angles are and what they're not. I'm going to number these, and I want you to tell me which ones are not vertical angles. But don't type it yet. I'm going to letter them, actually. Take a minute to think about which ones are not vertical angles, and I'll let you all type them at once. Okay, so I will now reveal the answer. The ones that are not vertical angles are this pair, and this pair. Any ones that you want me to talk about. CDE, December. YD. Okay, so vertical angles are angles formed when two lines cross. Two. Do you see two lines crossing here? That's three lines crossing. So it would have to be angle 1 and angle 2 right here. To make these two angles, I can't do it with two lines. I use 3 lines. That's next unit, Nathaniel. I know y'all already learned that, but we're not talking about parallel lines yet, okay? I'm not asking if they're congruent, remember? I'm asking if they're the vocab word. I'm asking if they're vertical. I'm not asking if they're congruent. So yeah, they might be congruent in letter D, but that's not what I was asking. A and E are vertical angles. They are. No, A is, because look, A is the letter X. They're across from each other. E, this is the letter X. Well, angle 2 is in the wrong spot. It was supposed to be right there. So the ones circled are not vertical angles. Don't write this down. This is in your vocab already. I just wanted to remind you. Yes, Catherine. Oh. These are not vertical angles because this is not the letter X. This is the letter K, like if you turn your head sideways. This is 1, 2, 3 intersecting lines, not 2 intersecting lines. They have to be, I can't say it any other way than letter X. You have to have the letter X, not a segment and then the letter V. Adjacent angles are angles with a common vertex. Okay, check. They're sharing a vertex. A common side. Check. We're sharing a side. They get along so well. I wish my daughters would share like them. And then no common interior points. So there's not a single point that's in angle 2 that's also in angle 1. So it just means adjacent angles can't overlap each other. They have to only share an endpoint and array. So let me show you angles that would be not adjacent. Angle 1 and angle 2. Those aren't vertical, those aren't adjacent, those are none of the above. We're not going to spend any more time on this page. Okay. Just a reminder, complementary means sum of 90. Supplementary means sum of 180. They add up, not their 180 by themselves. We can do A and B really quickly, but I kind of want to focus on part C. So what's the complement of 15? Go. Yep. What's the supplement of 15? What's the complement of 40? What's the supplement of 40? Okay, here's the next one. What's the complement of 20 minus x? We're going to assume that this is an angle measure. These were all angle measures. So to find A, we did 90 minus 15. To find B, we did 90 minus 40. So to find C, we're going to do 90 minus whatever the angle is. Now, you know from good old algebra rules that you're supposed to distribute that negative. So that's really 90 minus 20 plus x. And then you combine like terms. And you get, whoa, some of you got it. That was the right answer. What is the complement of 20 minus x? It's 70 plus x. Mind blown, right? So the supplement should be easy now. Oops, that was a weird X. Okay, let's move on. The supplement of an angle is 11 times as large as the angle. Find the measure of both angles. So the way we're going to solve this problem, the supplement of an angle is 11 times as large as the angle. What we're going to do first is we're going to draw two angles that are supplementary. These are actually a linear pair, and we're about to do that theorem in a minute, but we didn't get there yet. So what I'm going to do is I'm going to call, remember, I said whenever you have a problem and what you're looking for has no name, always give it a name. Assign it a name. So I'm going to look for this angle right here. And I know that its supplement is 11 times as large. I know that its supplement is 11 times as large. So now I can find the measure of these angles. These angles, by definition of supplementary, have to add up to 180. So we've got 12x equals 180. We've got x equals 15. Now, here's where students get confused sometimes. Did we find the angle or did we find its supplement? So like on a quiz, if I said, that, would you know which is which? The supplement is 11 times as large. So the supplement is the bigger one. The supplement is 11 times as large. So our angle would be 15 and our supplement would be 165. Okay, let's move on to our second theorem of the day. The first theorem was that, vertical angle theorem. The second theorem is LPT, the linear pair theorem, the LPT. It is is so common sense and so like, we already knew that, Miss Tanton. But it is its own theorem, so we do have to call it by name. If two angles form a linear pair, we did that in the warm-up, then they are supplementary. If they form a linear pair, so that's the condition. This has to happen. That's the hypothesis. The conclusion is they add up to 180. Linear pair angles add up to 180. Easy, easy. We learned two theorems today, and neither of them have a true converse. Neither of them have a true converse. Let me show you. So, the first one, those are a linear pair because they're adjacent and supplementary. The second one, those are not a linear pair. They're supplementary, but they're not adjacent. So just because they're supplementary doesn't make them a linear pair. But if they're a linear pair, then they're definitely supplementary. So it just doesn't work when you reverse the logic. Not synonymous. Good question, though. Good question. The hypothesis is linear pair. The conclusion is supplementary. It's always good to throw some real-world problems in there, right? We can't just solve everything with random rays on the board. So someone has a pool, and they have a nice deck around their pool. And the measure of the angle created by these two braces is 146 degrees. We want to find the measure of all the other angles. So we don't really care. I know this is the easiest problem in the world, but what I care about is can you back it up with a theorem? So let's find the measure of angle 2. The measure of angle 2 is what? 146, but I care about why. What allows us to say that? The vertical angle theorem. Dun, 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 the VAT. Very good. Okay, so now this is 146. What about the measure of angle 1? What is it? 34 degrees. That's all fine and dandy. What I care about is why. Oh, is it 44? No, it's 34. Why? How do we know angle 1 is 34 degrees? No. The linear pair theorem. Guys, we only learned 2 theorems today, so it's going to be one or the other. So angle 1 and the angle we were given, these form a linear pair. That's just a vocab word. Well, once we know they form a linear pair, then we know that they are supplementary. Okay, and then the measure of angle 30, is also 34 by the VAT. You could actually use either theorem to prove angle 3. Okay. I'm just going to dive right into solving this. If you want to pause it and put it in your notes, pause the recording, you can. Angle ABD is 3x plus 4. DBC is 56. Find x in the measure of ABD. Well, let's identify a vocab word. What kind of angles do we have? Linear pair, right? By the linear pair theorem, they are supplementary. Supplementary means they add, you put a plus sign, they add to equal 180. Don't set them equal to each other. I see it all the time, and it makes me want to cry. Okay, so then we combine like terms. Isn't algebra so fun? Don't you love just solving for x, like just going as fast as you can? Okay, x is 40, and then true or false. We could have found angle ABD with never finding x. True or false? True, right? We could have found this angle with never even solving for x, because we could have simply done 180 minus 56. So just when you look at a test or a problem, know that there's more than one way to get to that answer. If they were a linear pair, we could have found it without solving for x. GHJ is 2x degrees. JHI is 3x degrees. Find the measure of LHI. What I'm not going to do is, everyone listening, I am not going to call LHI x. I can't do that because x has already been introduced in my problem. I can't call it x because x represents a number, and I don't know that LHI is that number. So that's why I put a question mark instead of calling it x. Vocab word for these two angles. Vocab word. These two angles are a linear pair. You just have to kind of look to the side. Those two angles are a linear pair. So, by the linear pair theorem, we can add them to equal 180. They are supplementary, but how do we know they're supplementary? We know they're supplementary because they're a linear pair. So I want you to say linear pair instead. So x is 36. Now we get to use both theorems in one problem. Are you so excited? So now we're trying to find this angle right here. Well, they didn't tell us, is it 3x, is it 5x, is it 7x minus 2? They didn't tell us that angle. But that angle is vertical angles with GHJ. We know by the vertical angle theorem that LHI, the measure of it, is 2x, because that's the measure of the one that it's vertical with. So, final answer, picture not drawn to scale, 72 degrees. Cool? No, you can't assume it's a straight line if it's crooked. No, actually, when you had the assumptions lesson, it was a homework assignment. When a line looks straight, that was in the column of what you can assume. You can assume straightness of lines. It would have to be very clear that it's crooked. I would never trick you on purpose. All right, this is the last part of the lesson. I'm just going to finish up right here. True or false? Angle 5 and angle 8 are congruent. True. Why is it true? Vertical angle theorem. Angle 4 and 7 are a linear pair. And they're not a linear pair. They're not adjacent and supplementary. Angle 1 and angle 3 are complementary. And angle 1 and angle 3 are supplementary, not complementary. Angle 1 and angle 4 are vertical angles. True. Angle 5 and 7 are supplementary. Well, 5 and 7 are a linear pair. By the linear pair theorem, they are supplementary. Ding, ding, ding. True. Have a wonderful weekend.